LHCb discovers three new exotic particles, the pentaquark and the first ever pair of tetraquarks by CERN Phys.org. The new pentaquark, illustrated here as a pair of standard hadrons loosely bound in a molecule-like structure, is made up of a charm quark and a charm antiquark, and an up, a down, and a strange quark. The International LHCb collaboration at the Large Hadron Collider LHC has observed three never-before-seen particles, a new kind of pentaquark, and the first ever pair of tetraquarks, which includes a new type of tetraquark. The findings preserved today at the CERN seminar add three new exotic members to the growing list of new hadrons found at the LHC. They will help physicists better understand how quarks bind together into these composite particles. Quarks are elementary particles and come in 6 flavors: up, down, charm, strange, top, and bottom. They usually combine together in groups of 2s and 3s to form hadrons such as the protons and neutrons that make up atomic nuclei. More rarely, however, they can also combine into 4 quark and 5 quark particles, or tetraquarks and pentaquarks. These exotic hadrons were predicted by theorists at the same time as conventional hadrons about 6 decades ago, but only relatively recently, in the past 20 years, they have been observed by LHCb and other experiments. Most of the exotic hadrons discovered in the past 2 decades are tetraquarks or pentaquarks, containing a charm quark and a charm antiquark, with the remaining 2 or 3 quarks being a up, down, or strange quark or the antiquark. But in the past of 2 years, LHCb has discovered different kinds of exotic hadrons. 2 years ago, the collaboration discovered a tetraquark made up of 2 charm quarks and 2 charm antiquarks, and 2 open charm tetraquarks consisting of a charm antiquarks, an up quark and down quark, and a strange quark and strange antiquark. And last year, it found the first ever instance of a double open charm tetraquark with 2 charm quark and an up and down antiquark. Open charm means that the particle contains a charm quark without an equivalent antiquark. The discoveries are announced today by the LHCb collaboration include new kinds of exotic hadrons. The first kind observed in an analysis of the case of negatively charged B mesons is a pentaquark made up of a charm quark and a charm antiquark, an up, a down, and a strange quark. It is the first pentaquark found to contain a strange quark. The finding has a whopping statistical significance of 15 standard deviations, far beyond the 5 standard deviations that are required to claim the observation of a particle in particle physics. The second kind is a doubly electrically charged tetraquark. It is an open charm tetraquark composed of a charm quark, a strange antiquark, and an up quark and down antiquark, and it was spotted together with its neutral counterpart in a joint analysis of the K positively charged and neutral B mesons. The new tetraquarks observed with a statistical significance of 6.5 doubly charged particle and 8 neutral particle standard deviations represent the first time a pair of tetraquarks has been observed. ESR analysis imaging. ESR for catalytic mechanisms. Portable and easy to use desktop spectroscopy. The more analysis that we perform, the more kinds of exotic hadrons we find, says LHCb physics coordinator Niels Tuning. We are witnessing a period of discovery similar to the 50s, when a particle zoo of hadrons started being discovered and ultimately led to the quark model of conventional hadrons in the 60s. We are creating particle zoo 2.0. Finding new kinds of tetraquarks and pentaquarks and measuring their properties will help theorists develop a unified model of exotic hadrons, the exact nature of which is largely unknown, says LHCb spokesperson Chris Parkes. It will also help to better understand conventional hadrons. While some theoretical models describe exotic hadrons as single units of thinly bound quarks, other models envisage them as pairs of standard hadrons loosely bound in a molecule-like structure. Only time and more studies of exotic hadrons will tell if these particles are one the better the other of both.